joining me on Fascinating Frontiers, episode 123. It's July 6th, 2026. Starting the week with the latest from space and science, an asteroid set for a once-in-a-millennium Earth flyby could be seen by 90% of the world's population. Asteroid Apophis will pass unusually close to Earth during its 2029 approach. The encounter offers a rare chance to study a near-Earth object at close range without a dedicated mission. Ground-based telescopes worldwide will track the asteroid's path and surface properties as it sweeps past. The event ranks as one of the most accessible asteroid flybys in recorded history. Observers are already planning coordinated campaigns to measure any changes in the asteroid's rotation or shape induced by Earth's gravity. Follow-up observations after 2029 will test models of how such objects evolve over repeated planetary encounters. Now shifting focus from Earth's gravitational influence on a passing asteroid to China's first dedicated mission to collect material from one. 90% of the world's population could glimpse asteroid Apophis during its 2029 flyby. Ground telescopes will measure any tidal distortion or surface changes caused by Earth's gravity at a distance of only a few Earth radii. The geometry allows repeated observations over several nights from widely separated longitudes. Coordinated radar and optical campaigns will refine the asteroid's shape model and spin state to unprecedented precision. The data will test predictions of how close encounters alter near-Earth objects over time. What surface features might shift enough for even modest amateur telescopes to detect after the flyby? If Earth were scaled to the size of a basketball in downtown Toronto, Apophis on its 2029 approach would pass closer than the nearest subway stop. Tidal forces during such an encounter can torque the asteroid's rotation and fracture loosely bound surface material without breaking the body apart. The relative speed reaches tens of kilometers per second, so the entire gravitational interaction lasts only minutes, yet deposits enough energy to alter spin periods by measurable fractions. Precise tracking after the flyby will reveal whether the asteroid's rotation rate changed by even a few percent. The open question is whether repeated passages through the same gravitational keyhole could eventually steer the orbit onto a collision course centuries later. China's Tianwen-2 spacecraft reached the near-Earth asteroid on schedule and returned the first close-up images. The probe revealed a small, elongated rocky body roughly a few hundred meters across. Tianwen-2 launched in May 2025 and will collect samples for return to Earth. The mission marks China's first attempt at asteroid sample return. Scientists will analyze the material to compare it with meteorites already on Earth. Next steps include mapping the surface in detail before the sampling sequence begins. While one mission studies an asteroid up close, another telescope is revealing the universe's earliest giant black holes. The European Space Agency's Euclid Observatory detected 31 quasars shining when the universe was just 670 million years old. Two of these objects rank as the earliest quasars yet observed, each powered by a supermassive black hole. The light from these sources equals that of a trillion suns. Euclid's wide-field infrared observations allowed the team to sift through millions of galaxies to isolate these rare, bright cores. The detections pushed the timeline for the formation of the first giant black holes earlier than many models predicted. Further spectra from ground-based telescopes will help measure the black holes' masses and growth rates. From the first supermassive black holes to a nearby world whose habitability outlook has improved. Astronomers used the Hobby Eberly telescope to re-examine an exoplanet previously flagged as potentially too active for life. Refined measurements of the planet's radius and mass indicate a denser composition than first thought. The data suggests the world retains a substantial rocky component beneath any atmosphere. Researchers now plan additional transit observations to search for atmospheric gases. The updated parameters move the planet closer to the range considered Earth-like in bulk properties. Follow-up studies will focus on whether the atmosphere shows signs of water vapor or other volatiles. From individual worlds to an entire compact system shaped by a brown dwarf. An international team has characterized TOI 201c, the longest period transiting brown dwarf with a measured mass. The object sits in a coplanar system where its eccentric orbit influences the stability of inner planets. Data from multiple observatories, including ESO and ENAF facilities, pinned down the brown dwarf's mass and orbital elements. The configuration challenges standard models of how massive companions affect smaller worlds. Continued monitoring will test whether additional planets exist beyond the current known set. The system provides a laboratory for studying dynamical interactions over long timescales, from dynamical puzzles to a high-speed rehearsal for planetary defense. JAXA's Hayabusa 2 spacecraft passed within a few kilometers of the 450-meter asteroid at roughly 5 kilometers per second. The high-speed encounter gathered imaging and spectral data on the object's surface and shape. Mission scientists aim to refine techniques for future planetary defense scenarios. The Flyby adds to the spacecraft's extended mission after its successful Ryugu sample return. Analysis of the new images will help calibrate models of asteroid regolith behavior. Further encounters are planned as the probe continues its journey. From asteroid defense to seasonal weather on Mars, the European orbiter captured multiple dust devils swirling across one Martian valley during a recent imaging sequence. In Mars's thin atmosphere, the vortices can reach heights of 8 kilometers and speeds near 45 meters per second. The observations show how solar heating lifts fine dust high into the air, redistributing material across the surface. Repeated imaging passes allow scientists to track changes in dust devil frequency with season. The data feed into global circulation models used to predict dust storms. Future orbits will target other regions to build a broader statistical sample, from Mars weather to a nearby galaxy behaving like those in the early universe. An international team tracked a radio-bright galaxy 1.8 billion light-years away that has maintained elevated activity for more than 8 years. The central black hole is accreting fresh material and launching a high-energy particle jet. Archival and new observations show the jet remains powered long after the initial trigger. The system offers a nearby analog for the rapid black hole growth seen at higher redshifts. Continued monitoring will measure how the jet's power and direction evolve. The findings help calibrate models of feedback between black holes and their host galaxies. From black hole feedback to the chemistry of solar system formation, astronomers have compiled deuterium to hydrogen ratios from multiple comets observed over recent decades. The values differ between Jupiter family and Oort cloud comets, pointing to distinct formation regions. These isotopic fingerprints survive in the ices that make up comet nuclei. Comparing the ratios with those measured in Earth's oceans helps test whether comets delivered a significant fraction of terrestrial water. New measurements from upcoming comet encounters will expand the sample. The work ties directly into models of how the protoplanetary disk mixed material, from solar system chemistry to an easy naked-eye target this week. The Coma star cluster, also known as Melot 111, spans about 4 degrees in the constellation Coma Berenices, at roughly 40 degrees above the western horizon after sunset. The cluster is well placed for Northern Hemisphere observers. Its stars are bright enough to stand out against the background without optical aid under dark skies. The cluster lies only about 280 light-years away, making it one of the nearest open clusters. Observers can trace its triangular shape and note the contrast with nearby galaxies in the same field. The coming nights remain favorable before the cluster sinks lower each evening. From backyard observing to commercial launch partnerships, Skyroot Aerospace's Vikram-1 rocket will carry a payload from German company D-Cubed alongside Indian satellites. The mission represents the first orbital flight by a private Indian launcher. The German hardware tests deployment mechanisms for future CubeSat missions. European startups have limited dedicated small launch options, so the flight could open a new route to orbit. Success would demonstrate that Indian commercial vehicles can serve international customers. Additional missions are already in planning if the debut succeeds. From new launch routes to how artists once imagined them, a new exhibition traces how painters, illustrators, and filmmakers depicted rockets and spacecraft centuries before actual hardware existed. Early works show speculative vehicles that later influenced real designs at NASA and elsewhere. The show highlights how visual storytelling shaped public expectations of space travel. Curators note that many artistic concepts anticipated technical solutions later adopted by engineers. Archival sketches on display range from 19th century lithographs to mid-20th century concept art. The exhibition runs through the summer at a major London venue, from historical imagination to mapping today's global capabilities. The Center for Space Futures, Nova Space, and Space Tech Gulf signed a memorandum to build an interactive tool tracking national space assets and programs. The platform aims to give governments and industry a clearer picture of worldwide capacity. Data layers will include launch sites, satellite fleets, and workforce statistics. The partners expect the first public version within 2 years. The project responds to growing interest in understanding supply chain dependencies in the space sector. Regular updates will keep the dashboard current as new facilities come online. From capability tracking to NASA's lunar plans, NASA's newly appointed chief highlighted ongoing technology tests needed before humans return to the lunar surface. He noted China's stated goal of landing astronauts by 2029 as a benchmark for planning. Current Artemis hardware development focuses on landers and life support systems that must operate reliably for weeks. Isaacman emphasized that lunar operations will validate techniques later required for Mars. The agency continues to refine crew schedules based on lander readiness milestones. International partners are contributing elements that will fly on upcoming Artemis missions, from lunar timelines to expanding private investment. The two agencies formalized a partnership to steer private capital toward companies building critical spacecraft hardware. The initiative targets propulsion, avionics, and materials that support both government and commercial missions. Workshops and matchmaking events will connect startups with investors familiar with space requirements. Early focus areas include reliable small satellite propulsion and radiation-tolerant electronics. The program builds on existing NASA Small Business Innovation contracts. Progress will be measured by the number of new suppliers qualifying for flight hardware. New missions and instruments are steadily turning once theoretical objects into measurable targets. Keep an eye on the next round of Euclid data releases expected later this month for additional early universe quasar candidates. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. And before you go, this show is part of the NERA Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Models and Agents for Beginners, Artificial Intelligence Explained Simply for Beginners and Curious Teens. Find every show free at neuranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly